All right, let's get started. Today is the 19th. Yes. Ladies, gentlemen. I'm just going to start writing down names, and you're going to get a behavior log. If I have to address you again, you're just going to be removed. Okay. Before we get into today's examples, we need some formulas and some vocabulary. We're going to be talking about vertical motion. We're going to be using formulas. So these formulas are formulas used to calculate. Calculate height, time, distance, and velocity of an object. What's going on? Okay. The formulas we're going to use are as follows. We're going to have f of x is equal to negative 16x squared plus vx plus c. And f of x is equal to negative 4.9 x squared plus vx plus c. This bottom formula is going to be used for metric measurements. Do we know what a metric measurement is? No? Okay. So meters, centimeters, millimeters, anything like that is metric. Okay? We'll use the top one for non-metric. Feet, yards, inches. Okay? As of now, so for tomorrow's assessment, you're going to be given the formula that you're going to use. When we come back, you're going to have to figure out which formula to use based on the context, okay? In these formulas, we have different parts of it that mean specific things. C means, so when you have a number, some kind of number in for C, this is the initial height of the object. The initial height of the object. So if I'm standing up and I'm throwing a ball in the air, the ball isn't on the ground. It has a height from wherever I'm throwing it. That is what initial height is. Now, if you're kicking a ball, it might be on the ground. But it all depends on the context of the problem, okay? But it will, for right now, tell you what the initial height is. We will eventually figure out what that initial height is later. We will solve for it. Joelle. X will be time. Right now, time is measured in seconds, so we don't have to worry about that, but eventually it would change depending on the context of the problem. V is your initial velocity. We talked about velocity yesterday. For those of you who weren't here yesterday, make sure you watch the video and copy down the notes on the left side of the board. And f of x, or whatever we use to describe f of x, is the distance or height of the object. Am I going too fast? If I am, please stop me. Okay. Everybody's done? Okay. Yesterday we did level 2. Specific to level 3, I'm going to give you some information. So level 3, this is what you're going to need for level 3. In level 2, they give you the equation, and all you have to do is find the derivative. For level 3, you're going to need to create the equation. You're going to need to find V and C. That's all you need to find for level 3 is V and C. And it's given to you in the word problem. So all you have to do is make sure that you're labeling it correctly. The next thing you're going to have to do, is find the time the object reaches its maximum height. Or distance. Yeah, sorry. So when you throw a ball, almost always the ball or an object takes on this graph shape. This is called the parabola, okay? The maximum will be right here. It's at the vertex, it's at the top of the parabola. This is my maximum. When we talk about maximum, yeah. When we talk about maximum, we're talking about the point where it stops increasing, where it stops gaining momentum, stops gaining speed. Hi, Lily needs a break. Thanks. So, when it stops reaching speed, what is speed called in physics? Velocity, good. So, when it stops gaining speed, what is the velocity? Right, it will decrease, but it's still gaining velocity. It's 0. So we're going to have to solve for velocity when it's 0. Sorry, you're going to have to solve for t. How do I find velocity? How do I find velocity? What? Times? No. No. In calculus, how do I find velocity? Look at your notes yesterday. Lily, go. Come on, goes out there. If you don't have your notes, or if you write your notes on a piece of paper and lose them, it's also, what? First what? Derivative. Yes. Remember that velocity is the first derivative. So we're going to need to use the derivative. We're only going to need to use the power rule. So again, we are still doing the derivatives. We are still using the power rule. We're still multiplying and subtracting one. That's not new. We're just using it in the context of a real world problem. Okay? Real world problem. So I know some of you yesterday were stuck on the 1/3 as a coefficient. It doesn't matter what the coefficients are. What matters is that you're doing the process. Okay? Can I go down right there? The next thing you're going to need to find is the maximum height. This will be the maximum height after t seconds. So whatever you find in part B. Okay? Yesterday we were substituting in things. We're going to substitute in this number, but which function do you think we'll substitute it in for? Are we going to substitute it in for v of t or s of t? S of t. Did you say v of t or s of t? Yeah, s of t. This is velocity. This is not distance. So we need to make sure that we're using the correct thing to substitute. So we're going to use s of t, so our original function. Keep in mind, it's not always going to be s of t. It's not always going to be f of x. It's not always going to be y. You have to make sure that you understand that each problem may have different notation, but follow the notation that it has. And the last thing you're going to do is you're going to find the time it takes to reach the ground. The time it takes to reach the ground. When something hits the ground, what's its height? The height is 0. So we're going to need to solve for something or set this equal to something. What do you think? Which equation are we going to set equal to 0? S of t. S of t will also be set equal to 0. This right here is when we're going to need to use the calculator, okay? This is why you need to make sure you have the calculator. When you're done writing that down, take out the example sheet that Ashley passed out. Joelle, let me know when you're ready. Was that a you ready? Okay. You guys ready? All right. Joey. Okay. Am I going too fast?
No, you're good. We'll just...
All right, seniors. Ladies. Gentlemen. Can I get somebody to read the example, please? Go ahead, me.
An object is thrown vertically upward from a point 15 meters above the ground at an initial velocity of 49 meters per second. Use a formula. Mt equals -4.9 t squared plus vt plus c to answer the questions.
I said one person, but thanks. Part A asks us to create an equation. So we need to go through this to create the equation. When I'm reading it, I see that I have a point 15 meters above ground. I know then that this is my starting velocity. Not velocity, I'm sorry. My initial height. This is my initial height. This is where I start. So this is going to be C. Any questions on that? I know that this is initial velocity because it specifically says initial velocity. So this is going to be V. Are there any questions on that? Pretty simple, right? Or supposed to be. Now I'm just going to put these two numbers inside the formula to create my equation. T plus C. Any questions on part A? Any questions on part A? Okay. Part B now asks us how many seconds does it take for the object to reach its maximum height. So looking back at the level 3 information I gave you, you're going to need to first find the derivative and then set it equal to 0. Because the maximum height is reached when the velocity is 0. Maximum height is when the velocity is 0. Okay? So I'm going to take the derivative of this. I'm going to take the derivative of this. Some of us get confused when it's not whole numbers, but we can still take the derivative. We'll still multiply. 2 times negative 4.9 gives me negative 9.8. I subtract 1 from the exponent, that gives me t. Oops. Hey guys, why didn't you tell me I made a mistake there? There should be 15. Plus 49. Plus 49. A lot of you are still putting the t with this. This is a linear term. It has to take away one of the variables. There's only one there left, so it becomes 49. This has no variables, so it goes away. What is my notation for this? You don't know? No, not S of t. V of t. Right. Okay. What do I need to set this equal to? 0. So 0 is equal to negative 9.8t plus 49. This is just an algebra problem. How do I solve this? Okay. You said subtract 49 and you said what? Language. Okay. We're going to subtract 49 from both sides. I don't have room, so I'm going to do it up here. So I get negative 49 is equal to negative 9.8t. How do I solve this? Divide by t? Negative 9.8. This is just algebra. Why does my 9 look like that? T is equal to 5 seconds, but don't forget that you need to write a little sentence. So, the maximum height is reached. At 5 seconds. Oops. Questions? You look confused.
Notion of use is the max height, right?
Yeah. Good? Okay. Next part is asking me for the maximum height. So we have the time it reaches. Now we're looking for the maximum height. Looking back at the notes that I gave you, what am I going to need to do with this 5? Substitute it where? For which equation? S of t. So I'm going to need to substitute it into the original equation because this gives me height or distance. So S of 5. Can you see? Am I off screen? Somebody put this in their calculator. I think it's 137.5, but I can't remember exactly. It is? Okay. Are there any questions on that part? Would you get full credit for that? Why? You're missing your sentence. Maximum height. Bless you. Reached is 137.5. Would you get credit for that? Why? No units. Questions? Am I going too fast?
Yeah.
Well, you just came back from the bathroom. Can I go? Okay. All right, part D is asking how long it takes to hit the ground. What is the height when it hits the ground? 0. So what am I going to set equal to 0? S of t. Can I solve like this? No. What do you think I need to do? No. Use the calculator. You're going to use the calculator. When you're done writing that down, everybody take out their calculator, especially those of you who were not here yesterday.
Wait, after the app, which one? 7?
What?
You know how you hit app?
I'm going to have somebody tell me what to do after people finish writing this down, because I still see people writing it down. Christopher and Carla, do you need the sheet still? Because I just realized that. No? Okay. Are you ready? Oh, Pablo and Carlos, let me know when you're ready. Let me finish this. It'll take like 2 seconds, okay? It's really important that you don't miss this part. Ready? Okay. After I push apps, because I heard somebody say the first step, what do I push? 9. Okay. Any questions so far? And then we're going to push what? Number 1. What do I look for this top thing? The highest exponent. What's my highest exponent here? 2. So what do I do now that it's on 2? Hit graph. That'll take me to the next thing. For those of you who were not here yesterday, I know we're going a little fast, but I'll come around during the example and help you out, okay? What do I do now here? Plug in the what? Coefficients. If you have the bigger calculator, you have a list. So put it in the list. Just put the coefficients in the list. 49 and 15. After I put in my coefficients, what do I do? Press graph again. Now, you will see 2 answers. Only one of these is correct, because remember, these have to do with time, right? It would be what?
10.
It has to be the 10. Why is it the 10, Javier?
Because there's no such thing for negative.
There's no such thing as negative time. Okay? So after 10.3 seconds, the ball hits the ground. Oh, sorry. This one's an object, right? Not a ball. And yes, I will be petty. If it specifically says ball or rock or whatever, and you put object, you're not getting full credit. We're not going to do E. I realize that is a higher level standard that we'll get to in quarter 4. Oh, I'm sorry. I didn't realize I was off screen. Go ahead. Jacob.